Hi everyone, welcome to the new remote instruction. Hopefully it will it'll work fairly well. I know that it's all a little bit confusing, but we're going to work through it. And if for some reason these lessons don't end up working out very well, I'll try to find another way to do this to maybe hopefully help it do better. This is a little bit confusing for everyone, but we're going to get through it and figure it out. So as far as test 3 goes, there are 5 lessons on test 3. One of them we did in class last time we met. I know that seems like forever ago, but it was 4.2a, and it was about graphing the parabolas, so the quadratic equations, and the other lessons that are going to be on there are 5.1, 5.2, 6.1a, and 6.1b, which you can see that on Blackboard and on Hawks. We'll be going through 5.1 right now, and I'm going to try and do it as similar as, like, kind of a similar way that we did in class. I'm going to post a link to both this video and the notes. So if you haven't already, go ahead and pause the video, go print out 5.1 or get it on a tablet if you can write on there, or some way that you can fill in the blanks with me, and then come back to the video and unpause it and you can follow along with me. So same as usual, we'll be going through filling in the blanks and then working a bunch of problems. So I'm going to share my screen and just get right into 5.1a. Share my iPad screen so you can see it. Okay, and we'll be doing this lesson today. And if there are any questions that you have about this, or any issues you see with the video or with any of the math, hopefully I'll try not to make any mistakes. But if there are any issues, you can email me and let me know, and I'll try to address those and fix those if possible. And feel free to contact me, email me at any time, or tune in to the online office hours. I'm going to send an email about that and how those work. So today it will be 5.1, which is solving polynomial inequalities. So I think all of the inequalities in this lesson are already factored for you, so you shouldn't have to factor them, which is good. And so that'll cut down on a little bit of the time. And so these steps should be the only ones that you need. So the method that we'll be using to solve these is the sign test method. And this method has 4 steps. We'll go through the 4 steps, and then we will work a lot of problems using those 4 steps. So the first step is to find the zeros of the polynomial. And what we do there is set it equal to 0 and solve it, and you're going to get some answers there. And the answers are called test points. So these will not be your final answers. So if you do step 1 and write in the answers, then that is not going to be the correct answer and you will get it wrong. You've only done 1/4 of what you have to do for the problem. So in step 2, once you get those test points, you're going to plot them on a number line. And remember, when we do that, they need to be in numerical order. So if you have a -4 and a 3, then the -4 needs to go on the left side and the 3 needs to go on the right, because they need to be in numerical chronological order. So once you put them on the number line, that is going to split up your number line into little intervals. And in between these numbers, in each interval, you're going to pick a point. So choose any value in each interval, pick a point. And that is what we're going to test. And we're going to basically plug it back into the original equation and see if it's true or false. So once we see if it's true or false, if it's true, we will include that little part of the interval. If it's false, we won't include it. And so once we figure out which ones we're including and not including, we will write the final answer as an interval, so in interval notation. And that will be the answer to the problem. And so let's work this first example using that method. Okay. So we're going to start with step 1, which we set the polynomial equal to 0 and solve it. So right now, if we set it x minus 2, x plus 4, 1 minus x, set it all equal to 0. And that means that we'll set each factor equal to 0. So x minus 2 equals 0, x plus 4 equals 0, and 1 minus x equals 0. We'll solve those and get x equals 2. Well, actually, I'm not going to put a box around that because that's not the final answer. But we solve the next one, we get x equals minus 4. And then we will solve the last one. And we'll get 1 equals x, or I'm just going to write it as x equals 1, so x will stay on the left side. So let me, hold on. I'm going to make this a little bit smaller to leave us room for the next few steps. So in step 2, we will need to write it on a number line. So we'll draw a number line. And this is the part where we need to make sure that it's in numerical order. So the smallest one here is -4, so that one's going to go first on the left side. The one in the middle is 1, so we'll put it in the middle. And then the biggest one is 2, so we're going to put 2 on the right side. Okay. And so you can sort of see here that it's split the number line up into 4 different parts. So there's this part here less than 4, the part between 4 and 1, the part between 1 and 2, and the part greater than 2. And so since we have 4 parts to our interval now, or 4 parts to our number line, we're going to test 4 different numbers, one from each little part of the interval. And that is what we're going to do for step 3. So the first thing we'll do is we will test one from this first part of the interval, the part less than -4. So don't choose the points that you found in step 1 themselves. If you choose those, then you're just going to get equal to 0, and that's not going to tell you anything important. So we're going to want to choose a number in there that is not -4. So we'll choose a number less than -4 for this first one. So I'm going to pick -5. You can pick any number less than -4. I'm going to suggest not picking -1,786, but if you want to, go for it. So I'm going to choose -5 because it's easy. Okay, and then I'm going to plug that in to this original equation and see if that number makes that, well, not equation, inequality. I'm going to see if it makes that inequality true or false. So if I plug in -5, I've got -5 minus 2 times -5 plus 4 times 1 minus -5, so that becomes 1 plus 5, because the negatives cancel each other out, and then all of that less than 0. Okay, so now that we've done that, we can think about basically the sign of each one. So remember that this is called the sign test method. So we don't actually have to know the exact number, we just have to know whether it's negative or positive. So this first term here, -5 minus 2, well, that's a negative. The second one, -5 plus 4, is negative. And then the third one, 1 plus 5, is positive. So we're seeing if that is less than 0, because that comes from the original equation, less than 0. So negative times positive equals a positive number. And if we ask ourselves, is that less than 0, or positive numbers less than 0, then we'll know that our answer is no, it's not. So this one is a no. So this interval is not included, so it's a bad one. So we're not going to shade that part. We're just going to leave it alone and let it be by itself. Okay? So that is the first interval that we tested, and now we'll go on to the next one. Okay, so we need to pick something in between -4 and 1, and we don't want to pick those numbers themselves. -4 and 1 are not going to give us any good answers. So we're going to pick something in between. So 0 is a good one because 0 is in between there. 0 is always a good number. Okay, so if we plug in 0, we get 0 minus 2, 0 plus 4, and 1 minus 0 less than 0. Okay, so this first one, 0 minus 2 is negative. 0 plus 4 is positive, and 1 minus 0 is positive. And we see if that is less than 0. So negative times positive is a negative number, and that is less than 0. So what we got is an inequality that's true. And so since this one is true, we can write yes, and we can include that one. So this is good. We're going to, let me make that smaller. We're going to include this interval there. So go ahead and shade that one. Then we can test the next one. Okay, so we'll pick a number in between 1 and 2. We can't pick an integer, but we can pick 1.5. And since we're just testing to see if it's negative or positive, our calculations aren't going to be that hard, actually. So we get 1.5 minus 2, 1.5 plus 4, 1 minus 1.5, and then less than 0. We'll figure out if that's true or not. 1.5 minus 2 is negative. 1.5 plus 4 is positive. And 1 minus 1.5 is negative. So negative times negative is going to be a positive number. And that is not less than 0, so this is not true. And so we're going to say no for this interval. So it does not get shaded, and we can go on to the next one. Okay, so for this last one, we will plug in a number greater than 2, so a number from this interval here. And so I'm going to pick 3. 3 will be probably the best one. You want to pick 40 billion, go for it. I'm not. So 3 minus 2, 3 plus 4, and 1 minus 3 is less than 0. We plug in the 3 for x, that's what we get. And then 3 minus 2 is positive, 3 plus 4 is positive, and 1 minus 3 is negative. And we see if that's less than 0. Positive times negative is a negative number, and that is less than 0. So this is a yes. So this one is a good interval. So we're going to write yes there, and we're going to shade that. Okay. So we have the intervals that we need. We have them shaded. And now we just need to figure out what our endpoints are. So we need to figure out if it's brackets or parentheses. So if we do that, we want to look at this sign right here. So this sign is a strict inequality, so strictly less than 0. So that means we don't include the test points. And so this kind of sign always gets parentheses. So if we had had less than or equal to, if it was an inclusive inequality, we would put a bracket instead. Okay. So I'm going to put parentheses around those. And then we will do step 4. So I'm going to make step 3 a little bit smaller so that we'll have room for step 4 before going on to the next one. Okay, so step 4, we're going to look at these intervals from step 2 and 3 and just write them down. So this one here, we have from -4 to 1, and we have the brackets. I mean, sorry, the parentheses, not the brackets. -4 to 1, parentheses. From this interval here, we have 2 to infinity. And infinity always gets a parentheses no matter what, so you never include infinity because it's not a real number. And then once you put those two intervals together, you have to have a union sign in between them. And so in the end, this ends up being our final answer. -4 to 1 with parentheses, union 2 to infinity, both with parentheses. Okay, so that was the first example. And so if there are any questions about any of the examples on here, feel free to email them to me. I know usually I leave time for questions in class and I ask after each example, is there any questions? But since this isn't live, there's no way to do that. But feel free to email me or come to the virtual office hours if you have questions about these. So we're going to go on to number 2, and we're going to do the same 4 steps for that. Okay. So step 1, we set it equal to 0 and solve. So x squared, x plus 1, x minus 5 equals 0. And then we'll set each one of those equal to 0. So x squared equals 0, x plus 1 equals 0, and x minus 5 equals 0. If we solve the first one, we get x equals 0. We solve the second one, subtract 1, and we get x equals -1. And then we solve the third one, we add 5, and we get x equals 5. Okay, so these will be our test points that we will go on, and we'll put them on a number line in step 2. So step 2, we will draw our number line and put them in the correct order. So -1 is first, then 0, then 5. And then we will do step 3, which is testing each interval. So you can see here, just like in the last one, we have 4 intervals. 1 here, 1 in between -1 and 0, 1 between 0 and 5, and 1 greater than 5. So we will test the first one, which will test a number less than 1. Sorry, less than -1. Okay. So if we pick a number from there, I'm going to pick the number -2. You can pick anything you want to, but when we plug that in to our original equation, which is x squared, x plus 1, x minus 5 is greater than 0, we're going to get -2 squared, and make sure you put that -2 in parentheses, because if we put the negative on the outside, then we're not squaring the negative itself. We need to actually square -2. So make sure you put it in parentheses. And we'll do -2 plus 1, and then -2 minus 5. And we test to see if that is greater than 0. Sorry. I think I was scrolled up and you couldn't see that. Okay. So now we will test the sign of each one. So -2 squared is +4. So this first term here is a positive. And the next one, -2 plus 1 is -1, which is a negative. And then -2 minus 5 is -7, which is negative. We'll see if that's greater than 0. So positive times negative is going to be a positive number, and that is greater than 0. So this inequality is true. So we'll get yes right there. So here I'm going to write yes, and I'm going to shade that part of the interval to say we include it. Okay. So next we'll test one from in between -1 and 0. So we can test -0.5, or if you'd rather write -1/2, it doesn't really matter if you rather write it as a fraction or as a decimal. So if we do -0.5 squared, we have -0.5 plus 1, and -0.5 minus 5 is greater than 0. So in that case, the -0.5 squared, so a negative squared is a positive. It's negative times negative is positive. So this first one is a positive. Negative 0.5 plus 1 is going to be positive 0.5, so positive. And then negative 0.5 minus 5 is going to be a negative number. And so we will see if that's greater than 0. Positive times negative is negative, which is not greater than 0. So we've got that this inequality is false. So we're going to put a no there. And we're not going to shade that interval, so leave it alone. Okay. Next, we'll pick something between 0 and 5. I'll just pick 1 and plug it in. So 1 squared, you can put the parentheses there, but there's no negative, so it's not strictly necessary. It's fine if you do. 1 squared, and then 1 plus 1, and then 1 minus 5 is greater than 0. So 1 squared is positive, 1 plus 1 is positive, and 1 minus 5 is negative, and we'll see is that greater than 0. Positive times negative is a negative, which means that our inequality is false because it's not greater than 0, so that one is a no. So we'll write no for that one as well. Okay, and then the last one, we will pick something from this last interval, so something greater than 5, so I'll just pick 6. Okay, so 6 squared, 6 plus 1, 6 minus 5 is greater than 0. 6 squared is positive, 6 plus 1 is positive, 6 minus 5 is positive. And so positive times positive is positive, which is greater than 0. So yes for that one. And it gets shaded. So I'll do that. And then I will make this third step smaller and leave us room for the fourth step. Okay. So for step 4, we need to look at what our intervals are on our number line that we shaded. And so the first interval we have is here from -infinity to -1. And I did forget a step. I forgot to figure out what our endpoints are. So let's do that before we figure out the final answer. So if we look here, our sign is a strict inequality. So that means that we're using parentheses instead of brackets. So the -1 gets parentheses and so does the 5. And now we can go on to step 4. So this interval from -infinity to -1, the infinities always get parentheses. The -1 gets a parentheses because of this sign right here that's a strict inequality. And then we don't include these intervals, so we skip over those, and then we have this next one, 5 to infinity. And those both get parentheses as well. And we will put the union sign in between them like we do whenever we have more than one interval. And that is going to be our final answer. -infinity to -1 and 5 to infinity. And so that will be the end of number 2. Okay. So now we can go on to number 3 and do the same 4 steps. So all of these are going to use these same 4 steps. I think probably the only one that is a little bit weird comes at the very end. I think number 7 is probably the strangest of the ones we're going to do. And so whenever we get to that one might take a little bit more explanation. But I think for the next couple of examples, it's going to be pretty much exactly what we did in examples 1 and 2 with very little difference. But we'll go ahead and work them anyway, because more examples are better. Okay, so step 1, we'll set it all equal to 0. So x equals 0, x plus 4 equals 0, x minus 3 equals 0. When we solve these, we get just x equals 0 for the first one. For the second one, we'll subtract 4 and get x equals -4. For the last one, we'll add 3 and get x equals 3. So then in step 2, we can do our number line, put them in the correct order. So -4 comes first, and then 0, then 3. And then we will test things in each of the intervals. So you can see this one has 4 intervals as well. So one here, 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 and there. Okay. So from the first one, if we do step 3, which is the sign test, the first interval that we will look at will be the -infinity to -4 interval. So we'll pick something less than -4, so I'll pick -5. The -5, -5 plus 4, -5 minus 3 is less than 0. Okay, so -5 is negative, clearly. -5 plus 4 is negative, and -5 minus 3 is negative. So negative times negative times negative is a negative, which is less than 0. So that makes our inequality true. So that one is a yes. And so we shade that interval. So next we'll plug in something from this second interval. So something between -4 and 0. I'll pick -1. And so we'll plug it in and get -1. -1 plus 4. -1 minus 3 is less than 0. So we have a negative. -1 plus 4 is positive. -1 minus 3 is negative. And negative times negative is positive, which is not less than 0. So that is no. So no for that one. So no shading. Okay. For the next one, we can pick something between 0 and 3. So I will pick 2. And then plug it in and get 2. 2 plus 4, 2 minus 3 is less than 0. And so 2 is positive, 2 plus 4 is positive, and 2 minus 3 is negative. And then positive times negative is a negative, which is less than 0. So that's a yes, that one is true. And so we shade that interval. Okay, so last one on this example, we will do, we'll put 4 in because that's greater than 3. And so we'll get 4. 4 plus 4, 4 minus 3 is less than 0. So that is positive, positive, and positive. So positive times positive times positive is a positive number, which is not less than 0. So we've got a no for that interval. Okay. So now we finished step 3 and we'll go on to step 4. So let me shrink that. Okay, so step 4, we will look at these intervals and we need to figure out if we got brackets or parentheses first. So yet again, we have a strict inequality, so we've got parentheses. So parentheses for everything. So this first one, -infinity gets a parentheses because it's not a real number. -4 gets a parentheses because of the sign of the inequality. And then the next one we have 0 gets a parentheses because of the inequality sign, and 3 also gets a parentheses because of the inequality sign. And we put a union between those two intervals. So this one comes from here, and this one comes from here. Okay. And that is the final answer for number 4. Sorry, for number 3. All right, so now number 4, we'll do step 1. which is set it all equal to 0 and solve. X plus 2 equals 0, x minus 2 equals 0, 5 plus x equals 0. So subtract 2 here, x equals -2. Add 2 here and get x equals 2. And then we will subtract 5 on this one and get x equals -5. Okay. So now that we have those, we'll go on to step 2. Bless you. My mother's in the room, she sneezed. I don't think she has the virus though. I think it's just dusty. All right, so step 2, we will put it on a number line. And we'll do them in numerical order. So -5 comes first, then -2, then +2. All right. So now we will go on to step 3. So we'll pick a number for our first interval for the sign test. And so a number less than -5. So I will just do -6. Plug that in and get -6 plus 2, -6 minus 2, 5 minus 6 greater than or equal to 0. So -6 plus 2, sorry, make sure you can see that. -6 plus 2 is negative. -6 minus 2 is negative. 5 minus 6 is negative. And so negative times negative times negative is a negative number. And we think to ourselves, is that greater than or equal to 0? The answer should be no, because negative numbers are not greater than or equal to 0. So this one is a no for that. Okay, we'll do the second interval, -5 to -2. So we'll pick a number between those. I'll do -3. Plug that in, -3 plus 2, -3 minus 2, 5 minus 3, it's greater than or equal to 0. And then we'll do negative, -3 plus 2 is negative, -3 minus 2 is negative, and 5 minus 3 is positive. Negative times positive is a positive number, so we've got positive there, which is greater than or equal to 0. So yes there. And so we include and shade that one. Okay, so the next interval between -2 and 2, this one, there's a 0 in that interval. So if you can ever choose 0, that's probably like the easiest thing to plug in ever. So 0 is your friend. Let me change the color of that. There we go. Try to stay consistent in the coloring. Okay, so we'll do 0 plus 2, 0 minus 2, and then 5 minus 0, sorry, 5 plus 0, not that it matters, and then greater than or equal to 0. So 0 plus 2 is positive, 0 minus 2 is negative, 5 plus 0 is positive. Positive times positive is a negative, which is not greater than or equal to 0, so this one's a no. Not true. Okay. And then the last one, so a number greater than 2, so I'll pick 3. So we'll do 3 plus 2, 3 minus 2, and then 5 plus 3 is greater than or equal to 0. And then 3 plus 2 is positive, 3 minus 2 is positive, and 5 plus 3 is positive. So positive times positive is positive, which is greater than or equal to 0. So that one is a yes. And so we'll go ahead and shade that interval too. All right. So yet again, I will make this a little bit smaller so that we'll have room for step 4. So step 4, we will look at these intervals And first we need to figure out, are we using brackets or parentheses? So with this one, we have a inclusive inequality instead of a strict inequality. So we've got that or equal to part, which means we're going to use some brackets instead. So we get brackets around -5, -2, and +2. But remember, the infinities are special. They never ever get brackets. They always get parentheses. So don't forget that this is a parentheses right there. So for step 4, this first interval, -5 to -2, and they both get brackets. Then the next interval would be 2 to infinity. 2 gets a bracket. Infinity does not because it's infinity. And then since we have more than one interval, we're going to have to use a union symbol. So we've got the union there, and this is our final answer for number 4. All right. So now it's time for number 5. All right, so number 5, step 1, set it all equal to 0. X plus 3 equals 0. X minus 3 equals 0. 2 plus x equals 0. This one will solve it and get x equals -3. This one will solve and get x equals +3. And this one we will solve and get x equals -2. So step 2, those go on a number line. And so put them in the correct order, -3, -2, and 3. And then we will go on to step 3, which is the sign test. All right. So now let's pick a number in the first interval. We're going to pick something less than -3, so pick -4. And we're going to plug it into this, the original equation, just like we've been doing. Okay. So if we look at the first term, -4 plus 3 is going to be a negative. So that first little term is negative. And then -4 minus 3 is also going to be negative. And then 2 plus -4 is going to be negative. And we see if that is less than 0 because of this. So negative times negative times negative is a negative. And we think, is that less than 0? Negatives are less than 0, so this is a yes for that answer. And so this one is included, and we will shade it. Let's make that smaller. Good. All right. So now we will do the same thing with the next interval. We will plug in something between -3 and -2. We'll have to pick a number that's not a whole number, so -2.5 is going to be the easiest one, and we'll plug that in. So we do -2.5. This first term, -2.5 plus 3 is positive. -2.5 minus 3 is a negative. And then 2 minus 2.5 is going to be a negative also. And we think, is that less than 0? So positive times negative is going to be a positive number. So positives are not less than 0, so that one is a no. So no there, don't shade the interval. Okay, so then we will stick something in from -2 to 3. So that one has a 0 in it, so 0 is good. We're going to pick 0 and plug that in. So here, the first term, 0 plus 3 is positive. The second one, 0 minus 3 is negative. The third one, 2 plus 0 is positive. And is that less than 0? So positive times positive is a negative. which is less than 0, so that one's a yes. And so shade that interval, and we will go on to the last little interval that we have to test. Okay, so we need to pick something greater than 3, so I'll pick 4. So the first term, 4 plus 3, is positive. And the next one, 4 minus 3, is also positive. And then 2 plus 4 is positive. And we'll say, is that less than 0? Positive times positive times positive is a positive, which is not less than 0. So that one is a no. And we don't shade that interval. Okay. And so now, once I get a little bit of room here for step 4, so we need to figure out what signs we're using. So let's look at our original equation. We've got a strict inequality. So strict inequalities, we think, do we use brackets or parentheses? Strict ones give us parentheses. So all of these are going to get parentheses in them. So parentheses for all those numbers. So the first interval here, it goes from negative infinity to negative 3. They both get parentheses because of infinity and because of the sign. Then the next one, we've got negative 2 to 3. And they both get parentheses. And then we will put our union sign in between them. Okay, so final answer for number 5. So I'm trying to make this a little smaller to give us room for the next problem. I don't think that's working. I think I'll just keep it as is. Or maybe just make this part smaller. There we go. All right, so now we will do number 6. All right, so number 6, step 1, set all equal to 0. X equals 0, x plus 6 squared equals 0, and x minus 4 equals 0. Okay, so x equals 0. Don't have to solve anything there. X plus 6 squared equals 0. That would be like just setting x plus 6 equal to 0 twice. So I'm going to do x plus 6 equals 0, subtract 6 there, and get x equals negative 6. And then x minus 4 equals 0. We can add 4 and get x equals 4. So same thing here, we've got 3 numbers, and so we'll put them on the number line in step 2 in the correct order. So negative 6 first, 0 and 4. And then we will go on to step 3, which is the sign test method. So let's give ourselves some room for that. Okay. So for the sign test, let's pick a number from the first interval. So something less than negative 6. So we'll do negative 7. And we'll plug it into the original equation right here. So the first one, just negative 7 is negative. And then negative 7 plus 6 squared. So this time, since it's squared, anything squared is positive because positive times positive is positive and negative times negative is positive. So it's like this term here, kind of no matter what you put in, it's going to be a positive number. So in there, we're going to put positive. The last interval, negative 7 minus 4 is a negative. And then we'll say, is that less than 0? So negative times negative is a positive. which is not less than 0, so that is not true. And so no for this one. Okay, then we will try the next interval, -6 to 0. It's kind of too bad we can't choose 0 in this question because 0 is one of our points that we got in step 1, so we don't ever choose those. But we'll choose -1. Okay, and then we'll get -1 for this first thing. -1 is negative. The second one, since it's squared, is always going to be positive. And then -1 minus 4 is negative. We'll see, is that less than 0? Negative times negative is positive. Is that less than 0? No, it's not. So this one gets a no also. Okay, and then the next interval from 0 to 4, we will do, we'll pick 1. Okay, so I'll plug it in. 1 is positive. Then the second term is squared, so positive. And then 1 minus 4 is negative. So is that less than 0? Positive times negative is a negative. So negative less than 0, that is true. Negatives are less than 0. So yes there. And shade the interval. Okay. And then the last interval that we'll test will be the interval greater than 4. So we'll pick 5. So we plug 5 in, and we get 5 is positive. The second term, 5 plus 6 squared, since it's squared, it's already going to be positive. And then 5 minus 4 is positive. And is it less than 0? Positive times positive times positive is positive, which is not less than 0. So that one is no, that's not true. And we have finished step 3. So now that we have gotten step 3 over with, we can go on to step 4 and put in the intervals, put it into interval notation for the final answer. So since it is a strict inequality, we've got parentheses instead of brackets. So parentheses around 0 and around 4. And so our final answer is just that interval, just the 1, 0 to 4, both with parentheses. And since there's not more than one interval, no need for a union sign. Okay, so that's our final answer for step 4. Okay, so now we go on to number 7, which I think is the only weird one in the mix, in my opinion. For the most part, it's going to be fine until we hit step 4, and then we're going to have to do one thing just a little bit different. But we are going to do the same thing for steps 1 through 3. So step 1, set all equal to 0. X equals 0. X plus 3 squared equals 0. That would be like setting x plus 3 equal to 0 twice. So I'm just going to set x plus 3 equal to 0. And then x minus 6 equals 0. And then we'll solve for all of those. First one is already solved. The second one will subtract 3 and get x equals -3. The third one, x minus 6, will add 6 and get x equals +6. And then step 2, we will put it on a number line. Okay, so -3 comes first, and then 0, and then 6. And then we will do step 3, which is the sign test. Okay. Maybe I'll make it smaller so it'll all fit on the same screen. Okay. So for the sign test, we'll pick something from the first interval there. So we'll pick -4 because that's less than 3. And we will plug it into the original equation up here in yellow. So plug in -4. So -4 is negative. -4 plus 3 squared. Anything squared becomes a positive automatically, so that second term is a positive. And then we have -4 minus 6. So -4 minus 6 is negative. And we will say, is that greater than or equal to 0? So negative times positive times negative is a positive, greater than or equal to 0. So positives are greater than or equal to 0. That is true. So yes for that one. And shade the interval. Then we'll go on to the next one. So something between -3 and 0. So let's pick -1, maybe. -1. So we plug it into our original equation. So -1 is negative. Anything squared is positive, so the next term is positive. -1 minus 6 is negative. And we say, is it greater than or equal to 0? Negative times negative times, negative times negative is positive, which is greater than or equal to 0. So yes for that one. And we will shade this second interval too. Okay. So then we will plug in something from the next interval. We'll plug in something between 0 and 6. So I'm going to pick 1. Okay. So we plug in 1 into our original equation. So 1 is positive. Anything squared for the next term is positive. And then 1 minus 6 is negative. And we ask, is it greater than or equal to 0? Positive times negative is negative. Is it greater than or equal to 0? No, because negative numbers are not greater than or equal to 0. So we say no for that. And then the last one, we'll pick a number greater than 6. And I will pick 7 and plug it in. Sorry, I'm running out of room here a little bit, so let's zoom that out so we can see everything at the same time. All right. So now we put in positive 7. So 7 is positive. The second term is squared, so it's also positive. The third term, 7 minus 6, is 1, which is positive. And we say, is that greater than or equal to 0? Positive times positive times positive is a positive, which is greater than or equal to 0. And so we get a yes for the last interval. And so that one gets shaded as well. And so now we have done the first 3 steps, and then the last step is where we have to do just a little bit of thinking and a little bit of reasoning this out to make sure that we've got it correct. So our sign is greater than or equal to, which is an inclusive inequality. So inclusive inequalities get brackets. And what it means is all these numbers here, like 0, -3, and 6, are all going to be included in our final answer. So that's easy enough for 6 and 0. We're going to put a bracket around 6 and put a bracket around 0. But if we look here at the -3, it's like we have shading on both the right and left side of -3. So it's all the numbers on both sides of -3 are being included, and -3 itself is being included. So if we write 2 separate intervals for that, what we're saying is we're skipping over -3. So if we write something like -infinity to -3, we would have to put a bracket because of this sign, and then -3, and then go on up to 0. There's no need for this break in there because 3 is included anyway. So instead of writing it as 2 separate intervals on either side of -3, it's like we're just going to power through -3 and write that all as one big included interval. So I'm going to erase this. And what we're going to write instead is we're going to include this whole big section as one interval, where we don't stop at -3, we just go all the way through, and then we go on up to 0. So for step 4, we're going to start at -infinity. -infinity always gets a parentheses. We go all the way up, we do not stop at -3, go up to 0 instead, and then put our bracket. So it's like that goes all the way through and doesn't stop. And then the second interval works the way you would think it would. Just 6 to infinity, where 6 gets a bracket because of this sign right here, and infinity gets a parentheses because infinities always get parentheses. And then you'll put the union sign. So the reason that this happens, we've got a couple of things that are both going on that makes it work like this, where we power through the 3. It has to do with the fact that there are intervals on both sides of -3, and we have this bracket sign that includes -3. So if, for example, instead of having a inclusive inequality, if we had a strict inequality that did not have this extra little part down here, so if that went away and we had a regular inequality like this, we would not be able to include that -3. So if that was the case, we would do the -infinity to -3, which would get a parentheses, and then -3 to 0, which would get parentheses. But since we have the inequality sign being inclusive, we would have brackets for all of those, which means we would just power through, and then this whole break here would not be necessary. So make sure that you are looking at both the sign here and whether or not you have 2 intervals that meet. And if they do meet, think about, okay, that thing in the middle, is it included or not? And that will be dependent on this sign, the strict or inclusive inequality. Okay. So that is the end of this lesson. If there are any questions about it, or anything you'd like to go over, or if you have an example that you found on the homework from this section, feel free to email me or come to the virtual office hours on Zoom, and I'll be happy to talk about it. All right. I will see you when we do the next lesson.